So now you know what we mean by a polynomial. In this topic, we're going to learn new techniques to solve problems in the same way as we did with quadratics, but with higher degree polynomials. Before that, however, we're going to go back to some very basic number work and look at, for example, this calculation here. 39 divided by 5, we know is 7, remainder 4. There's some very important vocabulary involved here. We need to know what each of these numbers are called so that we can do things with our polynomials. The 39 is called the dividend, the 5 is called the divisor, the 7 is the quotient, and obviously the 4 is the remainder. So 4 pieces of vocabulary there for you to learn. We can then rearrange this and say that 39 is the same as 5 times 7, remainder 4. So in terms of the vocabulary that we've learnt there, 39 is the divisor times the quotient plus the remainder. And we're going to look just now at this remainder. When we divide one polynomial by another polynomial of lower degree, for example, a quadratic divided by a linear, or a cubic divided by a quadratic, or a cubic divided by a linear, we get two possibilities. We either get a situation where we're left with a remainder, or where the g of x divides exactly into the f of x, and therefore the g of x is a factor of the f of x. Now for higher, we will only be dividing by linear factors. We won't be dividing by any quadratics. We'll leave that for advanced higher. In particular, there is this very useful little remainder theorem that saves us a lot of time and effort, but it only works for dividing a function of any degree by x minus a. And this remainder theorem means that if we plug in the value of a into our function, we get what the remainder is. So it saves us doing any long, complicated divisions. That's what the remainder theorem is. And so we can have it looking at that. There's your divisor, there's your quotient, and now we know that our remainder is the value of the function when we substitute in a. To make this clearer, let's look at an example. It really is very, very straightforward. We're dividing by x minus 4, so our value of a is 4, so we substitute 4 into our function. 4 squared minus 3 times 4 minus 27 is negative 23, so our remainder is negative 23. No division having taken place, just using the remainder theorem. Second example. Notice this time it's x plus 4, but our remainder theorem only works for x minus a, but x plus a is the same as x minus negative a. So in this case here, we're using negative 4. The f of negative 4, when we evaluate that, is 1. That's our remainder, and that's the remainder theorem.